Okay, so far we've been doing ionic compounds between main group elements such as lithium and oxygen. And I just want to show you one more thing. Remember, lithium is in group 1A, so it has 1 valence electron. Oxygen is in group 6A, so it has 6 valence electrons. Lithium wants to lose its 1 electron. Oxygen wants to gain 2. When lithium loses its 1 electron, it is stable. However, oxygen has only gained 1, so it is not yet stable. So remember, we can have another lithium atom come and give its valence electron to oxygen, thereby making both of them stable. The formula, remember, for this is going to be Li2, since we have 2 lithiums, and then O. We don't have to write the 1 for oxygen. Okay? And remember to name this. The metal stays the same, the cation stays the same. So we have lithium, and then the anion we change so that it ends in IDE. So we have lithium oxide. But what I want to show you guys is a shortcut. Lithium, since it is in group 1 and loses 1 valence electron, will have a charge of +1 when it becomes an ion. Oxygen, gaining 2 electrons, becomes -2. Okay, does anybody see the correlation between the formula and the charges here? If you don't, here's what happens. The charge crosses down here, and this charge crosses down here. At this point, the positives and negatives don't count anymore, since now we're just counting number of atoms. And we still get Li2O. And again, we don't have to write the 1. Okay, and it works every time. For example, calcium has 2 valence electrons. Oops. And it will lose both of those valence electrons. Phosphorus wants to gain 3. So we're going to have 1, 2, making that calcium stable. So then, of course, what we need is another calcium. Stable. Since the second calcium is not yet stable, we can also have another phosphorus. Second calcium is stable, second phosphorus is not. So we have our last calcium. Making everybody stable. So the formula would be Ca3P2. The name of this compound would be calcium phosphide. If we do the shortcut way, which I've nicknamed the crisscross rule, we have calcium is going to be +2. Phosphorus is -3. We take the numbers down. And we get Ca3, 3P2. Okay, so let's do a practice run. We have calcium again, it's +2. Oxygen is -2. So using the crisscross rule, the 2 comes down here. Oops. This 2 comes down here. So we'd have Ca2O2. But if you notice, since this ratio is 2 to 2, it can be reduced to 1 to 1. Okay? And if you're not sure why that can work, look at calcium's Lewis dot structure. It has 2 valence electrons that it's willing to lose. Oxygen has 2 valence electrons that it's willing to gain. The formula of this would be CaO. When this is reduced, 2 can be divided by 2, so we get CaO. Like I said, it works every time. If you get numbers that can be reduced, reduce them. And if you're not sure, draw it out. Okay, what we're going to be talking about now is ionic bonding with transition metals. Originally, we'd been working with the main group elements. Now we're going to start working with transition metals. Transition metals are the B group here. And I've also highlighted a couple of these after the transition metals, these heavier metals, because they tend to act like transition metals. Now the term transition means that a change can occur. So the reason we call these transition metals is because they can have different charges. So when we're making compounds with them, we have to be very specific on which charge we're talking about, because the different charges affect the different compounds that are made. And the way we show the charges are as Roman numerals. For those of you that are unfamiliar with Roman numerals, I highly recommend writing this down. 1 is just an I. 2 is 2 I's. You might also see it like that. 3 is 3 I's. 4 is IV. And 5 is V. 6 VI. VII. VIII. IX. And then X. Okay. For example, if we have iron 2 reacting with chlorine, so what this means is that the charge of iron is 2. Because iron is a metal, it will be positive 2. Because metals will always lose their electrons. Chlorine, of course, is in group 7, which means it only needs to gain 1, becoming negative 1. So if we do it the crisscross way, we will get FeCl2. If you're still not sure about that, we can also draw it out. So we have Fe. Since it becomes positive 2, we're assuming it's losing 2 valence electrons. Chlorine, of course, has 7, being in group 7. So I can give here, and then we need another chlorine. 2, 4, excuse me, 5, 6, 7. And so coming over here, making both of them stable, and we still get FeCl2. Okay, let's try one more practice. Iron 3 oxygen, so this time iron has a positive 3 charge. Oxygen, of course, being in group 6, will gain 2 electrons, becoming negative 2. So the formula will be Fe2O3. Zinc 2 oxide. Since zinc now is positive 2, oxide, of course, refers to oxygen, so that's going to be negative 2. When we crisscross them down, we get Zn2O2, which of course can be reduced to Zno. It's a little more difficult going from formula to name. So, we know that Fe is iron. We know that Cl is chlorine, however, because it's in compound form, it of course ends in chloride. But since iron is a transition metal, we have to have the charge so that we know which iron we're talking about. So the way we do that is we do that crisscross rule backwards. So this 3 is going to go up this way. If there's no number here, that means it's a 1. Is going to go up this way. So then what we have is Fe plus 3, because the first one is always positive, Cl minus 1. Now we can check chlorines because it's not a transition anything. So if chlorine is correct, which it is, then iron must be correct. So this compound name is going to be iron 3 chloride. Okay, so now let's work on this one. We know Sc is scandium. And we know S is sulfur, but since it's in compound form, it's sulfide. Now we take the subscripts, cross them up, and we get Sc plus 3, S minus 2. Minus 2 is correct for sulfur, so that must mean scandium is correct, or 3 is correct for scandium. So we have scandium 3 sulfide. Okay, here's an example of one when it's not correct. We know Cu is copper, O is oxygen in compound form, oxide. No number refers to a 1, no number refers to a 1. 1 goes up, 1 goes up. So then we have Cu is plus 1 and O is minus 1. However, minus 1 is not correct for oxygen. It should be minus 2. So then we multiply it. What you do to one side, you do to the other. So then we would have copper 2 oxide. And it works the same way as that calcium and oxygen one did earlier. Would have 2 oxygen at 1, 2, 3, 4, 5, 6. Stable, stable, 1 copper, 1 oxygen, hence the 1s. So the 2s would have been reduced. Okay. For example here, Cr is chromium, P is phosphorus, or phosphide in compound form. No number means 1, no number means 1. Cross up, cross up. We have Cr plus 1, P minus 1. It should not be minus 1, it should be minus 3. So I multiply by 3. Multiply by 3. I get Cr is plus 3, P is minus 3, so I have chromium 3 phosphide. And that is how you do the transition metals. Work on your assignment, turn it in even if you do not finish.